Hello everyone, I'm Zheng Chengjun. Today we will present our project and the job recommend system, or you can call it JI. First, let me introduce this system. This is a centralized web-based recommend management solution designed to streamline end-to-end talent acquisition, automated checking, and secure corporate workflow management. Our group consists of five members: myself, Sanja, Yan Yibo, Shen Jue, and Zhao Yikai, working under the guidance of our industry supervisor, Chen Honglou, from the School of Computer and Information Science at University of Newcastle. So let's looking at the industry background. Managing talent acquisition efficiently is vital for enterprise growth. Many computer silent organizations still rely on fragmented and non-sterilized channels. Especially, they face legacy recommend bottlenecks such as fragmented email exchange and local spreadsheet checking. Information isolated across department polarized as data source, slow feedback loops causing communication delays, and a lack of unified grading continually leading to inconsistent evaluation among regulators. Beyond these operational seriousness, these ad hoc commercial approaches introduce major security and compliance series. Unincorporated resumes contain personally identifiable information are often stored on local drives, creating server P2 privacy risk. State document achievement cause sufficient control trials and prevent real-time standardization of candidate records. To solve these problems, our GIS solution goal is to build a centralized web-based platform that unifies end-to-end recommend workflows from internal job posting all the way to offer generation. Our project motivation centers around three core drivers. The first driver is the internal talent growth. We established an organized inter-talent acquisition process that um, empowers talent organizations to facilitate internal mobility, retain key staff, and build strategic talent pipelines efficiently. The second driver is reduce time to hire by automating application securing documentations and status updates. We significantly slash administrative costs and shorten overall hiring life cycles for HR teams. And the third driver is Python transparency. We demonstrate the OPQ hiring process by offering candidates a dedicated user portal where they can register, build modular profiles, track job status, and manage resumes dynamically. To validate our approach, we evaluated exciting industry solution against the manual method and our proposed platform. Enterprise ATS operations like Workday and Terra involve extremely expensive licensing fees, are overly complex with bloated features, and have regular SaaS struggles that are hard to automate and keep data third party hosted with slow user times. Conversely, manual methods using Excel and email have zero internal software costs, but are unstructured. Aerophone offer no conservativity, uh, carry high security and privacy risks, and suffer from version control chaos across inbox. Our proposed JIS platform bridges this gap. It provides a cost-effective house solution that is streamlined and purpose-built, tolerates directly to silent process, secured with RBAC and hashed P2 security, and features real-time periodic organizations for HR and the managers. GIS bridges the security gap between overall complex enterprise software and the insourcing manual solutions by offering an automated character fit recommend management portal.
Hello everyone, my name is Suhan Jia. My student number is C3543525. Okay, I want to talk on my page. This slide explains how we made the project feasible within the required 240 hours live timeline, and we divide the work into the four main parts. 50 hours for requirements and HCI design, 50 hours for the archers and the database design, and 100 hours for the full stack development, and 40 hours for the testing, quietly and issues and the documentations. So the large time product is development because it includes building the actual the pages. So the function and the system connection to manage the schedules. So we use the to weekly and Gantt chart updates. A short GitHub responsibly meeting minutes and struct the function scoping. This is help us to control the work line and avoid adding unnecessary factors. This slide shows the technical strengths of our team. So our team has the three main skill areas. The first is UI and UX design, where we use the Figma to create the prototype and regress the wireframes. The second is archers and modeling, including UML, use case diagram, so current diagram, and activity modeling. So the third is the database and the full stack development. It includes ER diagrams, SQL search design, HTML, CSS, JavaScript, and the React. So these skills are the complementary because some React. Some members focus on the design and the modeling, while others focus on the database and the implementations. So makes the project more balanced. This slide presents the five main objectives of the system. AMA is the self-regulation and account management, which allows a parish to the registrants, login, edit profiles, and upload the resumes. A and B is my main responsibility, job application submission and real-time checking. This is allows a pollution to search company vacancies, will view job details, submit one the focus application, and check the application status. It's based on the feedback. I changed this part from a board of the job. Market idea is into the single temporary. So requirement flow, which is more suitable of the project. AMC is for the HR post, adapt and close job business. AMD supports HR candidates review and status updates. AME sends automatic notifications when the application state change. Together, these aims connect the applicant side and HR side is into one requirement systems. This is side is explains our the HCI prototyping and the UX design. Methodologically, we use the Figma to design the interaction flow and the high friendly wireframes before codings. This is help us check whether the page layouts, buttons, and the user flow were clear. So we also applied to the HCI heuristic thinking to reduce congruent load. So application can search jobs and read the requirements and submit the applications so more easily. So the design also considers client views for the desktop and the mobile device. Finally, Figma works as the single source of the truth for the front-end implementations because it shows what the page needs to be built and how user move through the system. Thank you for everyone.
Hello everyone, today I am Yan Yibo. I am going to present the technological detail of our job recommend system, also known as JRS. I will focus on slide 9 to slide 12, covering our database design, front-end development system, strengths, and current limits. Let's start. Please look at the slide 9. This page shows our database design. To make our system strong and reliable, we use a structure called third normal form. In simple words, 3NF means we do not repeat the same data in different places. This keeps our data clean, organized, and free of errors. Second, below the main profile, we create 6 smaller tables: colors, history, education, clarification, skill, language, and resumes. Each table handles only one specific type of information. Why is this design good? First, if a user updates their profile, we only need to change it in one place. Second, if a user deletes their account, the system automatically cleans up all connected information. This keeps our database simple and fast. Now let's move to the slide 10. On the slide, you can see how we turn our design picture into real working web page. On the left is our Figma design prototype, and on the right is our actual HTML and CSS web page. If you compare them side by side, you can see the look almost identical. We active the pixel perfect translation. The buttons, colors, and layout merge the original design very well. During this step, our team also fixed an important problem named convolution. Earlier, some team members used the word application while others used the word candidate. To fix this, we created a standard dictionary. Now, all our code and design use a accent same word, which makes teamwork much easier and avoid bugs. Next, please look at the slide 11. First, easy and clear user journey because we carefully design all screens in Figma before coding. The web page is very simple to use. Applications can apply for job easily, and HR staff can review profit without confusion. Second, clean database design as a moment on slide 9. Our third normal form database prevents data mistake and keeps candidate information safe and accurate. Third, allow cost and focus. Big enterprise software like Workday can be very expensive and complicated. Our Satan provides only essential features that companies rarely need. It is cheaper, faster, and tailored to business need. Finally, let's turn to slide 12. We want to be honest about our progress. Certainly, we have three limitations that we are fixing in phase 2 of our development. One, database integration. Right now, our application database is finished, but the actual job posting database is still in a separate file. We are drawing them into one unfilled database script. Real data connection is to our web page correctly are not great, but they are static web pages. We are working on connections to the database using APIs so real data is show up live. 3. Automatic notification. We planted automatic email alerts for job schedule updates, but we still need to deploy this feature on the real server. Although these issues are planted and on track for phase 2.
Hello, my name is Zhao Yikai. Let me begin with the Figma prototype, because this was where the team first brought the whole system together visually. Before coding, each member designed their own part, but all the screens still need to feel like one complete product. By placing the applicant pages and HR pages in the same prototype, we could follow the user journey from one step to the next and check whether the layout, navigation, and the visual style were consistent. This also made problems easier to notice early, so we could adjust them before development began. We also prepared desktop and mobile views, which helped us consider how the same text would work on different screen sizes. Overall, the prototype gives the team a clear visual grid for implementation. Okay, next I will explain the database structure behind the application account and profile pages. The main goal was to store the information clearly, so we didn't place everything together in one large table. We separate login information from personal and career information, then connected the related records back to the career applicant. This allows one section to be updated without changing a related data. And it also helps the system keep each record linked to the right person. To support this structure, we use the primary and the fortune keys and follow the third normal form or 3NF. This reduces repeated data, makes the database easier to maintain, and prepares it for a secure implementation and integration with the rest of the system. Once the Figma design and database structure were clear, we began translating the Visuals prototype into working web pages. This cell compares the original design with the HTML version. The two sides are intentionally very similar because the goal was to preserve the appropriate layout during implementation. The profile page uses two main areas, with personal details shown on the side and information that applicants may update shown on the other. This helps users understand the pages without searching through many separate sections. During this process, we also checked whether the coded page still felt balanced and easy to follow, because a page can look correct in a design tool but not feel different after implementation. Another issue involved terminology, since team members sometimes use a different word for a same person. We agreed on shared terms before continuing, which reduced confusion and made it easier to connect the interface, database, and the future backend logic. Looking at what we have completed so far, one thing that stands out is how connected the system already feels. The phototype maps the four generate for both applicants and HR staff. So moving from one page to another should feel clear and consistent. The database also gives us a solid foundation for future development because the information is stored in a structured way. Repeated data can be reduced and the late updates will be easier to manage. At the same time, we have kept the project focused on the functions the client needs. This makes the system potentially to develop within the available time and easier to customize in the future. Of course, this doesn't mean that the project is complete. It just means that the work finished during the interface has given us a clear direction for the next stage. Okay, I will now hand over to the next presenter who will discuss the creation limited of the system.
Hello, my name is Shen Junye, and in my part, I will talk about the current limitation of GIS and data security and privacy, and our compliance framework and the next develop phase. First, our project currently has three main limitations. The first limitation is database integration, and the applicant database has already been designed in third normal form or 3NF. However, the HR job vacancy and candidate evaluation parts currently have separate database diagrams. In the next phase, we need to combine them into one complete SQL database structure. This will help all models use the same job application and the status information. The second limitation is backend API connection. At the moment, most of our interface are high fidelity prototype or static web pages. They can show the intended user experience, but they are not fully connected to the database records. In the next phase, we will use REST APIs to connect the front end with SQL database carriers. And the third limitation is the notification service. We have designed the notification process, but the server-side function has not been fully deployed. Later, the system should automatically notify candidates when their application status changes. This limitation leads to another important topic, security and privacy. And GRS handles sensitive personal information. This includes names, contact details, resumes, educations, work experience, and application history. Because this information is provided, the system design includes three important safeguards. And the first safeguard is password hashing, and passwords should not be stored as normal readable text. And instead, we use one-way hashing, and this means the original password cannot be directly read from the database, and even if the stored data is exposed. And the second safeguard is role-based access control, or RBAC. Applicant information should only be available to authorized users. For example, HR staff can review applications, but normal applications should not be able to review another candidate's resume or private HR notes. And the third safeguard is fairness. Final recruitment decisions should remain with human HR staff. The system can organize information and support the workflow, but it should not automatically reject candidates using an unsupported score. And after defining the security requirements, we also need to consider legal and professional standards. And the first standard is the Australian Privacy Act 1988 and the Australian Privacy Principles. These principles guide how personal information should be collected, stored, used, shared, and deleted. And GIS should only collect information that is needed to recruitment and should protect it from unauthorized access. And the second standard is Australian Cyber Security Centre Information Security Manual, or SCSC ACSC ISN. We use this as a guide for secure system design, user access, and data handling. The third standard is the OWASP Top 10. OWASP provides guidance about common web application security risks. And for GRS, important risks include SQL injection, cross-site scripting, and broken access control. These standards gives us a clear direction for the next implementation phase. They also help us test whether the final system handle candidates' information safely. And finally, the slides show our roadmap for the next development phase. The milestone 1 is the schema integration. We will combine the applicant, HR vacancy, and evaluation database design into the SQL schema. And milestone 2 is the backend API bundling. We will connect the current front and part pages to leave database records through REST endpoint. And milestone 3 is notification dispatch. We will develop the backend functions need to send candidates real-time updates when their application status changes. And milestone 4 is quality assurance and security testing. We will carry out system integration tests, check the main user workflows, and tests for common OWASP security problems. And we will have around 140 development hours planned for implementation and testing. And based on our current process, the main design work is complete, and the remaining tasks have been clearly identified. And to conclude, our next phase will turn the current design into a fully connected, secure, and testable equipment system. Yeah, and this is our references. Yeah, that's all. Thank you.